This is for Stats 2023. This is Chapter 7, Section 4, which is the last one. This is Example 2. Really the only major example in this particular work. This is hypothesis testing. This is the last test with proportions, but it's still a z-test. Remember, when we did our confidence intervals, proportions is always a z-test. No matter what you do, it's always a z-test. The problem states that a researcher claims that 51% of U.S. adults believe, incorrectly, that antibiotics are effective against viruses. So notice the word claim. So you already know what your claim is. So this is an equals. So we're going to make our null hypothesis P, because it's a probability, equals 0.51, and this is our claim. If the null hypothesis is equal, the alternative has to be not equal to 0.51. If we read further, we'll see that in a random sample of 2,202 adults, there's my sample size in, 1,161 say antibiotics are effective against organisms. So 1,161 is my X. That's very important. We're trying to determine something at the alpha of 0.1. So here's our statistics. All right, first of all, with proportions, we've got to go n times p. So it's 2,202 times 0.51. It's got to be greater than 5. And we can see that the math is going to be greater than 5. Then we go n times q. Now remember, q is just taking p and subtracting it from 1. So q is 0.49. If we go 2,202 times 0.49, it's also greater than 5. This tells us we're good to go on our proportions. We must do this every time on any kind of proportion test. We can see that our p hat is 0.527. The way we got the 0.527 was to simply take the 1,161 and divide by 202. That's how I got this 0.57. So, if I put this 1,161 here, I can either divide by 202 and it gives me 0.527. So this X, N, and P hat is very important. This is an equation that you're going to use a lot. P is 0.51, Q is 0.49. P times Q is 0.51 times 0.49, and then N is 2,202, and alpha is at 0.1. Remember, alpha. If our p-value when we calculate it is less than 0.1, we reject the null hypothesis. If our p-value is greater than 0.1, we fail to reject. Okay? So if we come here, what we're going to do is we're going to go to our menu here. We're going to move over to test. And if you look at number 5, that's one proportion z test. One means one sample. That's all we have is one sample. In the next chapter, we start working with 2 samples. So what I'm going to do is I'm going to move this down to where it's number 5. I'm going to press enter. And you can see I've already put in the 0.51, which is the p sub 0, or population proportion. I put in x, which is the 1,161. I put in the n, which is the 2,202. Remember, we got these numbers from here. 2,202 is n. 1,161 is how many out of the 2,202 responded correctly. Okay. And now we have to move down. And as we move down, remember, we've got to make this is the alternative hypothesis, and the alternative hypothesis is not equal to. So we're going to make sure our calculator is at not equal to. Now I'm going to go down to calculate. When I hit calculate, you can see I get z as a 1.62. I'm going to round it off. P is 0.105. Okay? So what happens here is, remember, our rule says that if P is less than or equal to alpha, we reject. This is showing that P is greater than alpha. Okay? And here's our Z, here's our P, And so P is greater than alpha. Alpha was 0.1, our P was 0.105. So therefore, we fail to reject the null hypothesis and the claim, because the null hypothesis was the claim.